Good day. We are still on the analysis of variance one-way classification. So the first example and the second example shows that uh, we have equal sample sizes or equal n for each k, right? So this time we are considering unequal sample sizes for each k. So in experimental work, one often loses some of the desired observations. For example, an experiment might be conducted to determine if college students obtain different grades on the average for classes meeting at different times of the day. So because of dropouts during the semester, it is entirely possible to conclude the experiment with unequal numbers of students in the various sections. So uh, if we are uh, comparing both ways, we have equal sample sizes and unequal sample sizes. So the advantage of equal sample sizes or having equal sample sizes is that the F ratio, right? The F ratio or katuin yung S1 squared over S2 squared is insensitive to departures from the assumption of equal variances for the K populations when the samples are of equal sizes or equal size. The second advantage is that the choice of equal sample size minimizes the probability of committing a type 2 error. And also, the computation of SSC is simplified if the sample sizes are equal, right? Kaya kung dirita sa unequal sample sizes, kung nakbantayan ninyo, di ba, ang sa equal, ang yang SSC computed as the summation of T sub I squared divided by N, or all over N, kani diri nga part. But for unequal sample sizes, each T sub I squared is divided by the number of sample n sub I. So, muna siya ang kalahian niya. Minus raman ni siya with this one. So, we now assume that k random samples to be of size n sub 1, n sub 2, up to n sub k. So, for each k sub 1, k sub 2, k sub 3, for example, ang n dire is mana siya ang unequal sample sizes. So, pwede man ta na atay 3 ka n lang dire sa k sub 1, sa k sub 2 na atay 5, sa k sub 3 is na atay 6 n. So 1 2 3 1 2 3 4 5 1 2 3 4 5 6. So dire na siya nabilong sa unequal sample sizes. So the degrees of freedom are then partitioned as for SST or the total, that is the capital N. Si capital N dire is the number of all. So meaning i-add lang ninyo ning n sub n, n sub 1, sorry, n sub 2 and n sub 3. That is the total number. That is capital letter N. So that is n minus 1. That is the degrees of freedom for the total sum of squares. And k minus 1 for the column means, and then n minus k for the error. Okay, so let's try with this example. It is suspected that higher-priced automobiles are assembled with greater care than lower-priced automobiles. To investigate whether there is a basis for this feeling, a large luxury Model A medium-sized sedan B, and a subcompact hatchback C were compared for defects when they arrived at the dealer's showroom. All cars were manufactured by the same company. The number of defects of the three models is recorded in the table below. So here, same gyapon. We have 1, 2, 3, that is k equal to 3. And then for k, the first model A, we have 1, 2, 3, 4. So n sub 1 here is equal to 4. And then 1, 2, 3, 4, 5, 6. N sub 2 here is equal to 6. 1, 2, 3, 4, 5. N sub 3 is equal to 5. So first, we compute or we sum up each column. So total, pilay total ani 4 plus 7 plus 6 plus 6, that is equal to 23. We have 5 plus 1 plus 3 plus 5 plus 3 plus 4, that is 21. 8 plus 6 plus 8 plus 9 plus 5, that is 36. And the total for this, 23 plus 21 plus 36, that is equal to 80. So 80 here is our t dot dot squared. This one, this is our t sub 1 dot. We have our t sub 2 dot and our t sub 3 dot. So those are the needed information or values for the formula to be computed. Okay, so test the hypothesis at 0.05 level of significance that the average number of defects is the same for the three models. So step number 1 is to state the hypothesis or the null hypothesis and the alternative hypothesis. For the null hypothesis, since we are having three populations here, so we have population mean 1 equal to population mean 2 equal to population mean 3. And then H sub A is equal, that is at least, okay, at least 2 of the means are not equal. And then step number 2 is our level of significance at 0.05. And then step number 3, that is the test statistic. So our test statistic here is still one way ANOVA. And then step number 4 is to establish the critical region for this problem. So the critical region, so for the critical region, still f computed is greater than the tabulated, where v sub 1 here is equal to, sa ganito, sa taas, v that is on the column mean, so k minus 1. So k minus 1, that is, k here is 3 minus 1, so that is equal to 2. And then v sub 2 is equal to, for the error, that is n, capital N minus k. And capital N here, capital N is equal to 15, since we have 15 here. 4 plus 6 plus 5. So we have 15. So total lang ani, that will be your capital N. So 15 minus k, k here is 3, so 15 minus 3, that is 12. So from your F table, at is 0.05 na F distribution, where V sub 1 is 2 and V sub 1 is 2 and V sub 2 is 12, that is your computed should be greater than 3.89 to reject the null hypothesis. Okay, so for the computation, katong gyapon, katong table gyapon. So let's make a table here. Wait lang. Okay. So we have the following table. Sorry for the line. So first we have the source of variation. And then second column will be the sum of squares. And then the degrees of freedom. Then the mean square. And the computed F, or our F ratio. So from here, we have the column means. For the column means, we have the error and the total. So for the column mean, ang inyong degrees of freedom ani is our v sub 1, which is equal to 2. And for the error, the v sub 2 that is equal to 12, then the total is 14. Okay, so let's compute for SST. SST again. SST. So, kato yung x sub ij squared. So, each of this. So, 4 squared, 4 squared, 7 squared. So, 4 squared plus 7 squared plus 6 squared plus 6 squared plus 5 squared plus 1 squared plus 3 squared plus 5 squared plus 3 squared plus 4 squared plus 8 squared plus 6 squared plus 8 squared plus 9 squared plus 5 squared, that is equal to 492. So you should get 492 minus the total t sub dot squared, or that is 80, then squared divided by the capital letter N, or the total. So we have 15. So that should be 65.33. And then for SSC again, katong, okay, since we are having different n, small letter n, so we will consider that. So we have 23 squared divided by 4 plus 21 squared divided by 6 plus 36 squared divided by 5 minus again 80 squared divided by 15, and then you will have 38.28. And then for the error, so this is no, sorry. Oh yeah. So 65.33 minus 38.28, that will give you 27.05. So for the sum of squares, for the column means, that is SSC, that is 38.28. And for the error, that is 27.05. And the total is 65.33. So for the mean square, that is, 38.28 divided by 2. So that will give you okay, 38.28. Mag-calculate sa ako ha. Divide 2 is, that is 19.14, and then 27.05 divided by 12, that is 2.25. And then computed F, that is 19.14 divided by 2.25, that will give you 8.5. So kung 8.5, if that is the computed, okay, so for the computed, since it's next ani, so that is step number 5, right? This is step number 5. And then, ibalik lang nako ha. Ingon siya, to get this, to make a statistical decision, your computed should be greater than 3.89 to reject the null hypothesis. So since we have a computed here, which is 8.5, so 8.5 is greater than 3.89, we should reject the null hypothesis. So reject the null hypothesis, and then we make a conclusion that the average, therefore the average number of defects for the 3 models is not the same. So that's it. So similar process for the one-way ANOVA of equal sample sizes. One-way ANOVA lang man gyapon but differ lang sila sa computation since we have different SSC. Okay, so for questions for this example, you may drop a question or a comment under this video dito sa classwork for me to answer it. Okay. Okay, so we are after the one-way ANOVA of unequal sample sizes, we are to test for the equality of several variances. Although the F ratio obtained from the one-way ANOVA procedure is insensitive to departures from the assumption of equal variances for the k-normal populations when the samples are of equal size, we may still prefer to exercise caution and run a preliminary test for homogeneity of variances. Such a test would certainly be advisable in the case of unequal sample sizes. If there is a reasonable doubt concerning the homogeneity of the population variances. So, kana siya. Suppose, therefore, that we wish to test the null hypothesis. So, we are having the null hypothesis and the alternative hypothesis here. And then we will use the Bartlett's test. This is based on a statistic whose sampling distributions provide exact values when the sample sizes are equal. So these critical values for equal sample sizes can also be used to yield highly accurate approximations to the critical values for unequal sample sizes. So we have the following. Anyway, you can read this from your lecture note, part number 7. Okay, so to illustrate the Bartlett's test, to test the hypothesis that the variances of the three populations are equal. So let's try to use example. Meaning example. Sige, dito sa katong example, kani siya nga example. Kaning unequal sample sizes. So let's try this using Bartlett's test. We are to test the hypothesis that the variances of the three populations are equal. So kay population mean manino, that is for one-way ANOVA. So if we are to test for the equality of several variances, we will make use of the Bartlett's test. Okay. So the idea is that, sige, use Bartlett test to test the hypothesis that the variances of three populations are equal. Okay, so step number 1 for the null hypothesis, so yun man siya, population variance are equal man daw. So let's test that one. Equal to, since we are having 3 populations. Kaning katong previous nga example atong gamitan. So HA is the variances are not all equal. So step number 2, we have alpha is 0.05. 0.05 yapon atong gamiton. And then step number 3 is the test statistics, so Bartlett test. Step number 4 is to establish the critical region. And if we are referring to the previous example, we have there n sub 1 equal to 4, n sub 2 equal to 6, and n sub 3 is equal to 5. Where capital letter N, the total of this, so 4 plus 6 plus 5, that is equal to 15. And K, or the population, is equal to 3, or the number of populations. So therefore, we will reject the null hypothesis if B is less than, okay, si 3 dire is ang number of population, and then we will make use of 0.05 alpha at n sub 1 equal to 4, 6, and 5. N sub 2 equal to 6, and n sub 3 is equal to 5. Okay, so if that is the case, so using the formula below, saan get to? Kani. So we have n sub 1. So ako lang ibutang ha. So n sub 1 there is 4. And then, what is the value of this one sa inyong Bartlett's table? So kung tan-awon nimo dito sa inyong Bartlett's table, dito ka mo tan-aw sa alpha nga 0.05, and then so this one 3 then 0.05 dito ka sa n sub 1, which is 4. Okay, 4 maning n sub 1 diri. So what is the value of this one? So sa inyong Bartlett's table, n there is katong, so n ninyo kani siya. So kung sa inyong Bartlett's table, di ba na diri n 2, 3, 4, 5, and then n 3, 4, 5. So since we have 3 populations, so dito ta mo tan-aw ani nga part. So diri ato ang kani siya is our k. So since k here is 3, so dito ta mo tan-aw ani nga column kang 3. And then n sub 1 is equal to 4 man. So unsa ni siya value ani? So according to your table, that is 0.4699. Tama? Ang isa, ang ikaduha, n sub 2 is 6 times. So, dito na po mo tanaw sa 6. So, same column, pero dito ka matanaw sa kang 6. And that is equal to 0.6483 plus man na siya, no? So, 5 times, dito na po mo tanaw, since n sub 2 not, n sub 3 na, sorry, is 5. So, dito mo tanaw aning 5. So, say value ana niya. So, that is 0.5762. Okay? So, divided by, so total ana divided by n man, capital letter N, so that is equal to 15. So, pilay answer ani. You should get, sige, ito i-compute. 4 times 0.4699 plus 6, tama? 6 times 0.6483 plus 5 times 0.5762 divided by 15. So that will give you 0.5767. So you should reject your null hypothesis if the computed value is less than 0.5767. So B is less than 0.5767. Okay, so for the computation, ang ato i-compute ani is ang S sub 1 squared ang S sub 2 squared and S sub 3 squared. So how will we compute that? So using the formula, okay, for the sample variances, so dito mo sa inyong calculator, you compute for the variances for each population. So for this one, so kaning 4766, inyohan ni siyang i-plug in dadto na data. So katong how to compute standard deviation. So pag makuha ninyo si Sx, inyo din na siyang i-squared to get the sample variance. So you should get for K1 that this is 1 point. This is 1.583, and then S sub 2 is for the population 2, that is 2.3, and then population 3, the sample variance is 2.7. Okay, so we will compute for S sub p squared here, that is equal to formula for S sub p squared is given by this one. So n sub 1 minus 1 times S sub 1 squared, or n sub 2 minus 1 times S sub 2 squared. Kana siya. So this is equal to n minus 1. N sub 1 minus 1 is 4 minus 1, that is 3, times ang inyong n sub 1 squared is 1.583 plus n sub 2 is 6 minus 1, that is 5, times 2.3 plus n sub 3 is 5 minus 1, that is 4, times 2.7 divided by, ito i-divide gani, n minus k. So sa inyong table, n minus k here is kani siya. Kani for sorry, n minus k, that is 12, or your v sub 2, that is the degrees of freedom for the error. So that will give you that is equal to 2.254. Tama? Okay, so next we compute for b. So b here is equal to, according to the formula, kung unsay mo ha kani siya, n minus 1 magyapon to, diba? So dito para klaro. So sa inyong formula, b is this one. So inyong sample variance 1 raised to power n sub 1 minus 1, then times sample variance 2 raised to power n sub 2 minus 1, and then up to sample variance 3 raised to power of n sub 3 minus 1. Dayon, kana silang tanan is erase pa yun na nimo power 1 over n minus k. And then divided by sp squared, s sub p squared. So this is, sige, balik ta. So si b is equal to 1.583 raised to power of n minus 1, which is 3, times 2.3 raised to power of 5 plus 2 point, not plus, dili siya mag-plus, mag-multiply ta, sorry, 2.7 raised to power of 4. Dayon, kana siya tanan is erase ni mo na siya 1 over n minus k na to is 12 divided by our s sub p squared, so that is 2.254, and that will give you, if you will compute that, that will give you, so that is equal to 0.9804. Sige. Okay, so accordingly, you should reject your null hypothesis if the computed, since our computed here is 0, sige, since 0.9804 is mas gamay ba? Mas dako siya kesa sa ato ang value or tabulated value, which is 0.5767. Mas dako man, dili man mas gamay, dapat mas gamay man. Dapat ang computed daw is mas gamay para ma-reject. Since 0.9804 is greater than 0.5767, we accept HO. So if we will accept HO, then we will conclude that the variances of the three populations are equal. So that's how you test for the equality of several variances. Okay, so if you still have questions regarding this topic, you may drop the question in the comment, and then I will try to answer those next meeting. So we will meet on Monday. Not sure na gina siya nga meet on Monday to discuss the questions and to discuss the remaining topic, which is the ANOVA, or the analysis of variance, that is two-way classification. So we have two different examples there, that is with interaction and without interaction. So we will discuss the without interaction, two-way ANOVA. Okay, so see you on Monday then. Thank you.